Hello, everyone. Thanks for joining. My name's CL Jolly, and this is my colleague, Sofia Esquivel, who is a low-carbon energy scientist. We're here today from the Environmental Defense Fund. It's a global not-for-profit organization focused on, well, our mission, really, is to stabilize the climate. And we do that using science, economics, sound policymaking, and industry partnerships in order to find the best solutions to really maximize climate benefits. So for hydrogen, we're here today talking about all of the investments that are going into hydrogen here today with many of you, how we can really maximize those benefits using the science. So I'll hand over to Sofia, who will give you a presentation on this.
Thank you. Hi, everybody. I'm so happy to be here to discuss the challenge of hydrogen emissions and how to overcome it. So let's start by discussing why do we care about hydrogen emissions. And those include venting, purging, small leaks, because hydrogen is the smallest molecule in the universe. So it's very slippery. It leaks through everything. So why do we care about that? Two obvious reasons: because they are a safety hazard, as the previous presenter said, and because they incur economic losses. But there is a third reason that is often overlooked, and that's because they can cause climate warming. And well, before I go into science, so since the 1970s, scientists have studied the warming effects of hydrogens. This is not new science. But during the last 2 decades, at least 15 published studies have confirmed the effects, they have reduced uncertainties, and they have build consensus around the science. So I'm a scientist, so I'm going to tell a little bit about the science. How does hydrogen warm the climate? So about 30% of the hydrogen that is emitted reaches the lower atmosphere, where it reacts with the hydroxyl radical, this OH on the equation. This radical is like a detergent in our atmosphere because it reacts with climate pollutants to reduce their concentration. So what are the consequences of this reaction in the atmosphere? The first one is that it leads to an increase in the concentration of methane, because methane is a potent greenhouse gas that usually reacts with this OH radical in the atmosphere. It's a natural process. But hydrogen is more reactive. So when hydrogen is in the atmosphere, it kind of takes up the place of methane, and then methane lasts longer in the atmosphere. The second consequence of this reaction is that the H produced, also a radical, it triggers a series of reactions that increase the concentration of ozone, the tropospheric one, the one in the lower atmosphere, and that's also a potent greenhouse gas. The third consequence is that the water produced at high altitudes has also an overall warming effect on the climate. So that's the science. And hydrogen's warming potency is stronger than that of CO2 per mass, but short-lived. So this graph here is comparing the global warming potential of hydrogen to that of CO2, which is the black line. And we can see that 20 years after one pulse of emissions, the global warming potential of hydrogen is between 30 and 40 times stronger than that of CO2. And 100 years later is between 8 and 12 times stronger. So how serious of an issue are hydrogen emissions? Well, the answer is that it depends. It depends on how much hydrogen is emitted across the hydrogen value chain, from production to distribution, all the way to end-use application. So the next question is, okay, it depends, but how much hydrogen is emitted today from the value chain? And unfortunately, there is no empirical data on the extent of hydrogen emissions from current infrastructure. And this is in part due to a lack of the high-precision, fast-response instruments, the sensors we need to measure site-level emissions and small leaks. So we have sensors to detect high concentrations of hydrogen that are that cause a safety hazard. But we don't have the sensors to detect very small concentrations that are not a safety hazard, but they are climate relevant. So without these sensors, still researchers have estimated the magnitude, the extent of hydrogen emissions from present and future hydrogen value chains. And as this graph shows, the estimates range from less than 1% for certain components of the value chain to up to 20% for others, like in this case, the yellow part in transport, that's referring to liquid handling. But I insist, these are not real measurements. They are estimations, calculations based on assumptions, theory-based models, and laboratory experiments. So the estimations are highly uncertain. Still, that's the data we have today, and they are valuable. So researchers have used these estimates to study the climate implications of hydrogen emissions. So in this slide, I'm going to present a study from Oko and Hamburg. The reference is below. And these researchers compare the climate implications of CO2 emissions from fossil fuel systems to methane and hydrogen emissions from blue hydrogen systems and to hydrogen emissions from green hydrogen systems. And for the emissions, they use a range. For methane, they use a range between 1% and 3% of emissions rate from the whole value chain. And for hydrogen, they use a range of 1% to 10% of the whole value chain, which is within the range of the estimated emissions that I showed in the previous slide. So the graph with the results compares the climate impact of blue and green hydrogen to the climate impact of fossil fuels. So anything above the line means that the hydrogen systems have a higher impact than fossil fuels, and anything below the line means that the impact is lower. So let's start with the result for the near term, because hydrogen and methane, they have these warming effects in the near term. So we can see, blues for blue, of course, that blue hydrogen systems with high emissions of both methane and hydrogen, they can be up to 40% worse than fossil fuel systems. However, if these emissions are mitigated to the lowest, blue hydrogen systems can be up to 70% better than fossil fuel systems. Green hydrogen systems are better in general than fossil fuels, of course. However, very important is that the climate benefits can be increased from just 50% to up to 95% if hydrogen emissions are mitigated. In the long term, both blue and hydrogen are better than fossil fuels. But again, if emissions of both methane and hydrogen are mitigated, the climate benefits are maximized. And that's what we need to achieve our climate goals, maximum climate benefits. So next question, okay? The hydrogen emissions have an effect. How do we minimize them? And fortunately, there are several actions we can take today to minimize hydrogen emissions. These include developing sensors that can detect very small leaks, again, the ones that are relevant for the climate, not only for safety hazards. We should measure emissions, and today we can measure emissions from venting, purging, residual hydrogen with current sensors, because those are not small leaks from the slippery molecule. That's a lot of hydrogen that's been released. We can measure that, we can quantify it today. The next thing we can do is to identify leakage mitigation measures, best practices, incorporate programs to measure hydrogen emissions, also for reporting and verification. And also, we have to include the risk of hydrogen emissions in decision making. And regarding measuring emissions, EDF, our nonprofit organization, is leading a hydrogen measurement campaign where we are using recently developed hydrogen technology from the company Aerodyne to quantify hydrogen emissions across the value chain. These very small emissions from leaks and also from the site level facility. And regarding mitigating emissions, this hydrogen measurement campaign will help us identify best practices and measures, because we're going to identify sources and magnitudes, but also there are best practices we can incorporate today, very simple ones, to minimize these emissions. So for instance, to minimize leakage, because hydrogen, again, is very slippery, it's very important to tighten valves and seals. It sounds obvious, but it's a best practice we all have to incorporate. We also have to use materials that are suitable for hydrogen. Not all materials are suitable for hydrogen. Some others are less permeable, like certain types of steel. To mitigate operational emissions, it's very important to recover and reuse the hydrogen that is vented, the hydrogen that is released into the atmosphere. And also, we can mitigate operational emissions from repairs by immediately repairing leaks and verifying that the repairs are successful, among other practices that you can find in this reference at the bottom of the slide that we will share later. So thank you for your attention. Like I said, these are the references. Everything will be uploaded to the app. So if you're interested in knowing more about best practices, the science, the measurement campaign, here are the resources. Thank you. I'm back to CL.
Thank you. So we have a few minutes left, I think. 1 minute left. If anyone has a question from the audience. Yes, sir.
Are best practices being included in certification and so on? You'd want that in order to be certified and get subsidies, for instance, that a plant, for instance, an investment would, kind of meet best practices, that it would be measuring leaks or something like that. Is that kind of thing happening in different programs in different countries, in IRA or in Europe? Thanks.
Do you want to go ahead, or?
Yeah, so that's what we want. We want to make that happen. I know that the UK is developing a hydrogen leakage mitigation plan where they are incorporating best practices. They are asking that for certification, they should incorporate it. To my knowledge, that's the only country that is doing that right now. But we are also working with the US to develop a hydrogen leakage mitigation plan for the hubs, including identifying potential sources of emissions, methodology we can use today to measure and quantify, and more additional best practices. But it's something we're working on. Thanks.
Yeah, maybe just to add to that, I mean, I think as with many things in the hydrogen space at the moment, everything's sort of developing in parallel. So certification, standards, regulations are being developed as we speak at international level and nationally as well around the world. And so we're looking basically to bring the science to that decision-making and to that planning in order to make sure that the certifications do include some of those sort of specificities that really matter for, for maximizing the climate impact. So very much a work in progress. Mm-hmm. I think our time is up, so thank you very much. Mm-hmm. And Sofia and myself will be around for another 10-15 if anyone has any last questions or would like to discuss further. Otherwise, feel free to contact us through the app as well. We'll be here for the next couple of days. Thank you very much.